Hey, thanks, Bill. I realize I am standing between the next presentation and your next drink. So if you're empty, I'll hurry. If you still have anything left, drink it up because it makes my presentation better. Trust me. Okay. All right, Chad Spring from Enervenue. Hey, everybody. I'm here to talk about nickel hydrogen batteries. Now, before I do that, though, you're probably saying, hey, that tall guy up there looks really familiar. I just wanted to set the record straight. I am not related to the Property Brothers. Okay. I am also not related to John Mulaney. Okay. Great. We're all level set. So let's talk grid scale stationary energy storage. Graph going up means good things if you're in the battery space. Okay. That's the punchline here. Just grid is going up. That's all. So nickel hydrogen chemistry originated from NASA, deployed in outer space, then Stanford University refined it back in 2017. Enervenue was then spun out of Stanford in 2020 with the mission of scaling up nickel hydrogen. You can see one of our energy storage vessels, or ESVs, here behind me. It's about 6 feet tall, so almost real scale. Within that, we have a stack of electrodes. There's also a water electrolyte solution. When the battery is being charged, that water splits. You're left with hydrogen gas. I'm getting really nerdy. That's why I said drink. That gas, then, when the battery is being discharged, recombines back with water. So a fully kind of repetitive cycle. Now, that chemistry brings really, really long life. No fire risk. It's recyclable at end of life, unlike lithium batteries, and very, very low cost over the entire life of an energy storage project. Now, kind of diving into some of these, it's super durable, so 30,000 charge and discharge cycles over its 30-year life. And you can really charge and discharge that however you want, so it's super versatile. Now, from a safety standpoint, no fires. I'm happy to talk to you later about what happens. We'll see actually in another slide what happens if there is an external fire. And fully sustainable, so there's no lithium, very easily sourced, recyclable materials as well. So again, very flexible in how it's charged and discharged. Also, just really flexible, and I'm waiting for the next slide. So diving into that safety aspect. So putting nickel hydrogen chemistry in a bonfire. You would never do this with any other battery, right? It heats up as that hydrogen recombines back with water when it gets hot. The battery then vents out steam. So it literally extinguishes fires rather than propagating. This isn't funny. This is true. Don't laugh at me. So it's really quite amazing. So ways to deploy nickel hydrogen chemistry can deploy in buildings, right? You can see in the center there. So think giant wine racks. I know I'm making you thirsty. Giant wine racks of batteries. Also DC block enclosures like you would see in what's common in today's battery world. All of that plays really nicely with all different use cases on a utility grid. So I'm not going to dive into all of these, but paired with renewables, stationary energy storage, also paired with commercial and industrial facilities to reduce cost, eliminate time of use demand charges, and also really improving resiliency if there is a grid outage. Also with residential energy storage. So because of that fire safety message, being able to deploy these into attics, into crawl spaces, areas where lithium batteries would never be placed. So cost, right? Punchlines at the bottom. Enervenue cost versus lithium cost. I'm not going to dive into all the numbers. Lithium or nickel hydrogen batteries are far more cost effective over the entire life of an energy storage project. Now, of course, there are product improvement roadmaps. We are, over the next couple of months and next year, improving the energy density of the nickel hydrogen ESV that you saw, improving that by 50%. So how do we make these, right? We are scaling up rapidly. We just announced a couple weeks ago our gigafactory coming online in Kentucky a very red state with a lot of renewables, right? Pretty exciting. So that's in 2024 and scaling up globally after that. Punchline here, third-party report analyzed all different energy storage technologies. Summary is nickel hydrogen chemistry is poised to take over battery storage of the future. Thank you.